Hey everybody, I hope you're doing well at your homes and learning some new exciting things along the way. So as we continue on with our unit and learning about solutions, let me make this a little bit bigger. So there is a note packet that goes along with this presentation that you can print out, or you could take free notes. It's up to you, but once again, just recognize you will be able to use your notes when you take the quiz. Just like last time. So taking good notes should help you with learning the information, but then also for that as well. Okay, so these are kind of the ICANs we're looking at. Number one, I can identify what a solution is and what concentration means. You should have been introduced to that concept for those of you that have done and read the AIG lab. If you haven't, get that done to get caught back up. And then we'll talk more about that one today. And then 11.2, I can draw a solution at the molecular level. We're going to learn that one today. And then 11.3, I can define and calculate molarity. That's also what we're going to learn today. So these three ICANs, you should be able to give yourself a ranking on after doing the lesson. And then 11.4 is next time's lesson. And you'll have practice with that one as well. Okay, so let's jump into this. Okay, so concentration measures the relative amounts of two substances making up a solution. So there's two components that make up a solution. You have the solute, that is the substance being dissolved, and then you have the solvent, which is the liquid doing the dissolving, and then the solution is a combination of two. Once again, a key thing about what we call a solution is that when something becomes a solution, you can't see the different components anymore. It looks like one thing, right? Labeled at the beginning of the year as it's homogeneous. I know some of you struggled or mixed that up a little bit when you took the quiz last time. So there will be, there's a bonus quiz today as well to make up some of those points if you would like from the AIG post-lab quiz. So it's bonus, you don't have to do it, but if you'd like to make up some of those points or get some extra credit, you can do those. And it'll just have you practice separating, once again, what's a solute, what's a solvent, and then what makes it a solution. Okay, so with concentration, okay, so these are relative terms, but when we say something is concentrated, we're referring to that it has a high amount of solute per solvent, and then dilute would be a low amount of solute per solvent. Once again, they're relative to each other because something can be concentrated in one situation and another. But for example, we could say that the Great Salt Lake is very concentrated with salt versus like your tap water. And it's even more concentrated than like the ocean is. One of the cool things that we will see is if it's a colored solution, it becomes darker as the concentration increases. And we'll do a little lab next week that kind of deals with that with Kool-Aid and kind of seeing the differences of them. But I'm sure you're all familiar with that even with Gatorade or any other drink that you make, that the more water you add, the lighter the color becomes, and we'd classify that as a more dilute solution. Sorry, trying to figure out. Okay, here we go. So let's do these two questions for two smiley faces here. Okay, so all four beakers below contain solutions of copper 2 sulfate. First question says, which solution is the most dilute? Second question says, which is the most concentrated? I'll give you 30 seconds to make your choice. Okay, it's not quite 30 seconds, but I think you probably got it by now. So if you selected that D, most dilute, you are correct. You have a smiley face. If you select that A is most concentrated, you can have a second smiley face. So once again, kind of just that connection of color to concentration. Okay, so solutions at the molecular level. Once again, key thing is at the molecular level, we know the solution is actually made up of, even though at our level, we can't see those two things, right? So an ionic substance dissolves in water, they break apart into ions. We mentioned this back when we learned about ionic substances and we did that lab in that unit where you had to identify if a substance was ionic, covalent, or metallic. And one of the tests you could perform was you could stick that little electric probe, right, into the water and see if it would conduct. And ionics would always conduct, metallics never conducted, and covalents would sometimes conduct. Once again, the reason why ionics always conduct is because they break apart into and I'm going to flip over to my board to draw this out with you. Okay, so the reason why ionic substances conduct once again is because they don't stay together. They actually break apart into positive and negative things. And when you have positive and negative things floating around in a solution, it can conduct, or I guess not even in solution, but anytime positive and negatives can move, that's what allows electricity to flow. So for example, if I have sodium chloride here as a solid, so I'm going to put a little S next to it. If I dissolve it in water, so I'm going to put it above the arrow because it's not really reacting with the water in what we're looking at here, but it's going into the water. Okay, so when the sodium chloride goes into the water, it breaks apart. And so we get Na separate from the Cl. Now, they don't break apart into their elements, they break apart into their ions. So this is where you have to go back to finding their charges. So you go to the periodic table, you find how many valence electrons they have, and then find their charge. So sodium has a +1 charge, and chlorine has a -1 charge. And if you need a review on how to find those charges, let me know, message me, and I can help you out with finding those charges if you've forgotten how to do that. Okay, so next one here we have magnesium chloride. Same thing, it's going to separate into its separate pieces, so we're going to have magnesium. And then notice that this little 2 that's here is going to come out front because it's separating to every individual thing, right? Little numbers mean they're connected, big numbers mean they're separate, you just have 2 of them. And then same thing, put their charges. Chlorine has a -1 charge, magnesium has a +2 charge. Okay, last one here, separate it first. So we're gonna have 3 strontiums and 2 nitrogens. Once again, noticing the little numbers come out front, and then we have their charges. So we have strontium with a 2+ charge and nitrogen with a -3 charge. Okay. Now, let's draw a picture of what that looks like floating around in the water. So that's what in the box right below these, you can draw this picture. Okay, so we're going to draw a picture of sodium chloride, but it would be the same idea no matter which one you choose to draw. Okay, so I'm going to first draw my 2 separate things in there. So I have 1 sodium and I have 1 chlorine. Okay, now if we were drawing this one, you would draw 1 magnesium and 2 chlorines. Okay, so make sure you have the ratio in there. Now the second thing you're going to draw is the water. Now we've talked about before back in the unit when we learned about polarity that water is a polar molecule. And what that means is that water has a positive and negative side. It's a little magnet. So this is how we're going to represent water. So water is H2O. So to draw it, we're going to draw our O in the middle, and then our 2 H's on it, and it's going to look like a little Mickey Mouse. The reason why, once again, reviewing back, it looks like a little Mickey Mouse is because the idea of how water is a bent molecule, because we have the ghost down here that we won't draw, pushing those hydrogens together. And so water, once again, looks like a little Mickey Mouse. Okay, now water, once again, is polar, and one side is positive and one side is negative. The hydrogen sides are positive, and the oxygen side is negative. And so what happens is when your salt, so this right here is salt, okay, so when I pour it into water here, if I were to do so, they would separate because of the water's little magnet, and it pulls them apart. So since sodium is positive, it's going to be surrounded with water like this. where the negative side of the water is attached to the positive sodium. The chlorine is negative, and so notice the Mickey Mouse is going to be flipped, where the hydrogens are attached like so. Okay? So there's a few questions on your homework, and you'll see some later on the quiz that are like that as well. And it's all about the positive and negative orientation of how it lights up. Okay, so the next thing we're going to talk about is how the mathematical, scientific way in which we measure concentration in chemistry, the main way. There's another way of doing it, or other ways of representing it, but molarity is the main way in which we represent the concentration of a solution, and it gives it a numerical value. So the first thing we need to know is what molarity is. So molarity is a measure of how many moles of a substance are dissolved per liter of solution. Okay, and we can clarify it as moles of solute. Okay, so molarity is how many moles are dissolved in a liter. So when you take those two numbers, divide them, you get the ratio, and then it represents its molarity. So once again, if I wanted to make a certain molarity of salt, I'd measure out that many moles, dump it in that much water, and I could find its molarity, or get the molarity I want it to be. So when you see a molarity, molarity is represented by the capital letter M. So when we see this capital letter M, it's telling you the molarity of that solution. So this is saying that we have a 2 molarity solution of hydrochloric acid. What that is telling us is, well, since molarity is moles per liter, because it's 2M, that means you have 2 moles of HCl per every 1 liter of solution, which if it's not specified, the solution is like most of the time water, because that's the primary solution that we use. You could dissolve it in something else, but most of the time it would be water. So that's what this means. Okay? All right, let's take a look at that first problem of how we can find the molarity of something. Okay, so our problem says this. It says find the molarity of a 250 milliliter solution containing 10 grams of NaF. So first thing, just like before, when you're problem solving, the best thing is to identify what you're trying to find. So the thing I'm trying to find is molarity. So I'm going to circle that. And now let's write out what molarity is. So molarity is moles per liter. So there's 2 things I need to find the molarity of a solution. I need the moles of the solvent over the liters of my solution. Okay, so let's figure out what the problem is giving us. The problem gives us 2 parts. So it gives us milliliters of solution, and it gives us 10 grams of that. So we're going to have to do some conversions here to get it to the units that I want. So the solution is in milliliters, so we've got to change this into liters. The solvent, or the solute, is in grams, so we need to change that into moles. So we're going to do 2 side conversions to then plug in to the equation. So whenever the problem says to find molarity, you've got to do 2 separate things. Okay? All right, let's start with our solution. Okay, so I have 250 milliliters, and I want that to be in liters. So milliliters goes on the bottom, liters goes on top, and it's been a while, but hopefully you remember that there's 1,000 milliliters in 1 liter, and that's always true. So we get 0.250 of a liter. Okay? All right, then, so that's what we can plug in. To the bottom bottom of our fraction for liters. We then are going to take our 10.0 grams of NaF, okay, and we need to convert grams into moles because that's the top of our fraction here. So, gram to mole conversions. This is where we're going to use the molar mass. So I'm going to add up the mass of this. Okay, so the mass of that when I added it up was 41.99. Remember to always keep 2 decimal places with every mass that we do. That should all keep us fairly uniform with our answers. And there's for one of them. I divide that through and I got 0.24 moles. Okay, so that's going to go on the top of my fraction. So once again, notice when you're finding molarity, we did 2 separate steps and then we brought them back together because molarity's a combination of the 2. You kind of think of it like finding the density of something, right? To find the density of something, you got to find the mass and then the volume and then divide them, okay? So when I divide that through, I got 0.96, it's really close to 1. And then the units for molarity are, you could write it a few ways. You could write capital M, or you could also write 0.0 or 0.96 moles per liter. Both of these mean the same thing, it's up to you. So that's how we find molarity. Okay, let's take a look at these next few problems that are going to talk about how molarity can be used to connect different units together. So our first one is how to find it, but now we're going to talk about how molarity actually fits onto our map that we've been using before. We've just kind of ignored this bottom part because last time we've just been going this direction, but now we're going to bring in this bottom portion. So the first key thing that you need to recognize here is molarity is a conversion unit. Notice that it's a road, it's in between, it's not a starting point and it's not an ending point. That's why if you're trying to find molarity, you don't really use the map because it's 2 things connected together. It's moles and liters, okay? But if you're trying to find grams or liters or particles, molarity can help connect you there based on what's given. So let's take a look at problem number 2. So problem number 2 says how many grams, so right away I'm going to circle what I'm trying to find, of NaCl are required to make 0.5 liters of a 0.25 molar NaCl. Now first off, this map's in your notes, so make sure you fill it in. These who are familiar, this is our new one, right? The molarity connection. Okay, so the trickiest part with this is understanding where am I going to start. So the first thing to remember is that you don't ever start with molarity. Because once again, molarity is a road and you don't start on the road. You start at your house, then you travel down the road to your destination, right? There's my silly analogy. Okay, so the place I'm going to start is I'm going to start at liters, okay? The second thing here is to remember what molarity tells you, okay? Molarity tells you how many moles there are per liter. So in this problem here, 0.25 m is telling me that there's 0.25 moles per every 1 liter. That's what this is what that means. Because capital M is moles per liter. Okay, so if I take a look at my map here, we've underlined liters, so I'm starting here in the blue, and I've circled grams, so I'm trying to get up here to the green. So this is going to take me 1, 2 conversion steps to get there. So let's take the thing that we underline, and once again, notice my colors. To follow the pattern, so we have 0.5 of a liter is where we're starting. Okay, just like all conversions, liter is going to go on the bottom because we want it to cancel. And then the unit we're trying to get to is going on the top. So I'm going from liters to moles. So mole will go on the top. Okay, step one. Then I'm leaving mole. I'm going to put mole on the bottom. And then grams is where I'm trying to go, and those are connected, moles to grams, so that will go on the top. Okay, so once again, liters, moles, grams. Once you have your road set up, then you can set in your relationships. So the thing that connects these two is the molarity, right? So the molarity is 0.25, which always goes where the mole is for every 1 of a liter. And then moles to grams is always connected through the molar mass of the substance. So I'm going to find the mass of NaCl, which I found to be 58.44 over 1, because every 1 NaCl is that many grams. Plug it into my calculator, and I got an answer of 7.31 grams of NaCl. Just like last time, there was a discussion board where if you have questions as I'm going through this that you're confused about before you start the homework, you can post it on there, and I'll try to get back to you as quick as possible to help you out. Okay, let's take a look at number 3. So number 3 says how many moles, so right away I'm going to circle what I'm trying to find, excuse me, of HCl are required to make that many liters of a 6 molar hydrochloric acid solution. So I'm going to underline what I'm starting with. So I'm starting with liters, because once again, molarity is a conversion factor, so you don't ever start with molarity. Kind of just like you would never start with a molar mass. You don't ever start with molarity, but we're going to use the molarity to connect our units together. Okay, so coming to my map here, I'm starting in liters. I'm going to moles, so this is actually only going to be a one-step problem. So I'm going to take what I'm starting with here. So 0.25 of a liter. Okay, once again, liter will go on the bottom because I want it to cancel. Moles goes on the top because that's what I'm trying to find. And it only takes one step to connect the two. And then the thing that connects moles to liters is the molarity. So that's what's given right here. And that has to be given. If we're using liters and we need to get to moles, they have to give you the molarity of it. Otherwise, you're stuck. You have too many unknown variables. So remember, molarity is, this tells us that there are that many moles in every 1 of a liter. So it's 6 to 1. Okay, plug that into my calculator, and you get an answer of 1.5. So 1.5 moles of HCl is how many you would need to make that solution. So often with most of the labs that we do, at least up to this point, we've used different molarities of solution. You just haven't known that because I make them ahead of time. And so this is literally actually what I have to do to figure it out before we do the lab, is I figure out how many I need to dissolve and how much water to make our certain molarity. Okay? All right, we're going to do one more problem today, number 4. What I'd like you to do is, if you feel okay with this, go ahead and pause the video and try it yourself. And then start it, and then you can check your work and see how you did, because there's no better way to practice than to practice, and then check yourself afterwards. Okay, let's take a look at number 4 here. Hopefully you were brave and tried it on your own, and so we'll see how you did. Okay, so this one says how many grams of NaOH are required to make that many liters of that much molarity. So I'm starting with liters, so I'm going to write that first. Whoops, we'll follow my color pattern here. Okay, And then the thing I'm eventually trying to get to is grams, but I'm starting here in liters, so it's going to take 1, 2 steps. So let's set up our steps. So you should have said, okay, the first thing we're going to do is go from liters to moles. Let's change up that marker. Okay, and then we can go moles in grams. Okay, set up your steps, plug in the relationships. So moles to liters is connected through molarity. So you should have plugged in that there, it's 0.45 to 1. And then grams to moles is connected through molar mass, which the problem actually gave us. We don't have to add that up ourselves, to 1. Plug it in your calculator, and you should have got an answer of 13.5 grams of NaOH. And there's your answer. So if you got that on your own, you got a great place to start the homework. If you didn't, and you have further questions, send me a message, post it on Canvas. I'll get back to you, help you out. We can do, I've been doing some virtual video conferencing with people who need it, so don't be afraid if you're confused to reach out to help, because that's what I'm here for. Yeah, so just like last time, you'll do the homework assignment first, then you'll plug your answers into Canvas for 2 reasons. Number 1, that's how you'll get your points for the assignment. Number 2, it will help you know that you're doing it correct, which is more important than just getting points. You have 3 attempts to plug it in, so if you do it wrong, there's a help document you can click on that shows you some of the work for the problems, so you can see if you can find your own mistakes. If you can't find your own mistakes, send me a message. The best way is if you do have a specific question on a problem, it's also helpful when you send your question to send a picture of your homework with it, so I can see what you're doing, and then I can help you figure out what's not working. Okay? All right, that's it. Good luck, everybody. Stay home, stay safe, and talk to you later.